In this lesson, we're going to be looking at applying the concept of factoring to a very specific purpose, which is we want to take a quadratic trinomial, so something in the form x squared plus bx plus c, and we want to factor that, put that into factored form. There are a couple of ways that we can do this. I'm going to start with what you might think is maybe a more intuitive way. I'm going to revisit some of the work we've done with algae tiles, and then I'll show you how that corresponds to an area model. And then we'll also look at an algebraic technique, which is actually what we want to move towards. So let's start off by looking at algae tiles. So if I've been asked to factor x squared plus 4x plus 3, the first thing I should do is actually assemble x squared plus 4x plus 3. So this is why this is an easier way to do things, because I really just start with, in this case, x squared, and now I need 4x's. So I'm going to show you a mistaken or one that won't work first. So let me start with 4x's like this. So there's 4x's, and now I have to put 3 somewhere. But with the rules of algae tiles, I have to match lengths of sides. So I can't put this 1 along here. I can only put this 1 here. But as you can see very quickly, well, that's not going to work. I've got an open space hanging here. I've got an open space here. But we have to make some sort of rectangular shape. And the more squarish our rectangular shape, the better. So if I take this one away and instead put in a horizontal one, because the shape of this, whether it's horizontal or vertical, that part doesn't matter. Well, now you can see I actually have that nice rectangular shape that I'm looking for. And from that, I now have my x plus 1, 2, 3 along the side, and I have an x plus 1 along that side. So the top is x plus 3, and the side is x plus 1. And as I've discussed in my previous lessons where I'm talking about algebra tiles, this is an area model. So a length times a width gives me a total area. A length times a width gives me a total area. In the previous lesson, I looked at starting from factored form and then expanding the brackets using algebra tiles. Now I'm using the algebra tiles to actually go the opposite direction, show that these things are equivalent. What if I wanted to do the same thing on paper? What if I didn't have enough tiles, or I didn't have any tiles at all? So now if I want to do the same thing, the way that I do that is what's known as an area model. So now I'm going to simulate using tiles. And the way I do that is I draw 4 equal boxes, and in this top left tile, just like on our algebra tiles, the x squared goes in the top left and my constants go in the bottom right. And then I fill other things in as I can. So this I have 1x squared, so that's my number of x squareds. Here's my constant, that goes in the bottom right. And now what I need to do is figure out, well, what combination of x's do I put here and here so that this works out? So first of all, if this is x squared, then this must be x by x. X by x gives me an x squared. Now what are the ways that I could end up with a 3 here? What times what will give me a 3? Well, I could do a 1 times 3, so a positive 1 times a positive 3. That would work. And what would that give me for x's? This would become a positive 1 times x, so that's going to be x. And this would give me an x times a positive 3. That's going to give me plus 3x. That's plus 1x. And if I take a look at these diagonals, plus 3x plus 1x is a total of plus 4x, and that does work. So using the exact same logic as I did before, I end up with x plus 1 times x plus 3. Now that is exactly what I got before, except for in the previous example using algebra tiles, I had a plus 3 up here and a plus 1 down the side. That doesn't matter. These factors are reversible. The ordering does not matter in this case. So let's do another algebra tile example. X squared plus x minus 6. So x squared. And now minus 6. Well, this is already going to make things more complicated. So now what you want to do, since we know, just like in the area model, we know we want to put our tiles, our constant tiles, in this case negative 6, we want to put those down here in the corner. So there are a number of ways that I could arrange to make negative 6. Here's one way I could do it. Just 1, 2, 3, 4, 5, 6, or in this case negative 6. Now what can I do with my plus x to do that? Well, obviously I could put a plus x there. That doesn't make a rectangle. I could put a plus x here. That also doesn't make a rectangle. And I have one other option, which is I can make use of, let's go back to this plus x. I can use the fact that a plus and minus add up to 0, so they don't actually add anything in. So I could actually say, okay, well, how about I do a plus x here and a minus x here, because that plus and that minus that I just added in, they don't add anything. So this is still overall, I've got plus x plus another x, that's 2x, minus x is still just 1x. But I don't have a rectangle. So what I need to do is reconsider this, and I have to reconfigure. So what's another way that I could represent this negative 6? Well, not only is it 6 across, I could do 2 by 3. Does that help me to do this? Well, if I go one step further, if I add in another positive 1 and I add in another negative 1, I've added 0 total, but now I've made my rectangular shape, and across the top here I have an x and I have plus 3. Down the side I have x and I have minus 2. Remember, all colors, even if you add in positives or negatives, they have to be the same. So I couldn't say plus and a minus and a plus and a minus. These are all minuses down here, these are all pluses here, and this appears to work. Plus 3 times negative 2, so I end up with x plus 3 across the top, x minus 2 along the side. And again, the order that you write these factors is not actually important. Let's look at the same example as an area model. Now, when you do the area model for something like this, you're going to want to have an eraser handy, because there's some trial and error involved. And I'm not going to, obviously I know my answer from the previous sheet. I know this is x times x, because it's just x squared. Now I've got negative 6. Well, how can I make a negative 6? There's actually a number of ways. Well, first of all, let's just ask ourselves, how can I make the number 6? The number 6 could be 6 times 1. The number 6 could be 2 times 3, 3 times 2, 1 times 6. And then to make that positive or negative, well, I want to make that negative. So that means I could do negative 6 times 1. I could also do 6 times negative 1. I could do negative 2 times 3, or I could do 2 times negative 3. I could do negative 3 times 2, or I could do 3 times negative 2. I could do negative 1 times 6, or I could do 1 times negative 6. Now, thankfully, at least for these simple trinomials that we're doing right now, where the coefficient in front of the x squared is 1, we only have to do one of these sets. We only have to try these. We don't have to try both. But later on, when things get more complicated, you actually need to try both combinations, because they could be different. Because this is a 1x squared, the two combinations will be equivalent. It won't matter, but later on it will matter. So let's start with this one. I could put a negative 6 here, and I could put a positive 1 here. Positive 1 times negative 6, this works, and this corner works, but x times negative 6 is negative 6x. X times positive 1 is positive x. Negative 6x plus x is equal to, these things together are going to be equal to negative 5x. But that is not the same as that. So unfortunately that means we throw that one away and we back out, or we have to redraw what we did there. And it turns out that, oh, so let's get rid of that. And now let's try -2 and +3. So now we do x times -2 is -2x. X times +3 is +3x. I combine these together. +3x minus 2x is equal to +x. And that's what we have here, +x. So it turns out that this is the correct configuration. X minus 2, and down the side, x plus 3. So you can see there's a little bit of trial and error that goes into what we're doing here. And I actually realize now, if I did this really logically, I would have actually done -6 times 1, -3 times +2, and then -2 times +3. So just by jumbling things by accident there, I actually saved myself a little bit of time and effort. As you get better with these things, you might start to be able to make predictions about them, but you have to start somewhere, and sometimes it's just going to be a process of elimination. Okay, the other option we have is algebraically, and this also involves some of that trial and error that we looked at before, but it's a slightly more methodical way, meaning there's a little bit more of a process. So to understand where this comes from, and if you've been following what we've been doing with the area model, this shouldn't come as too much of a surprise to you, which is, take a look at the numbers here. So I've got the number 1 in front, I've got the number 5 times x, and I've got the constant 6. So what relationship is there between the factors, meaning these? What is the relationship between the factors and the coefficients of the answer? For these, what do we call simple trinomials, this is 1x and this is 1x, so 1x times 1x gives me 1x squared. We don't actually consider that. It's not to say that it's not important, it's just it's not relevant to the discussion we're having right now. So let's now instead, let's focus on strictly, let us focus on 2, or more precisely, +2 and +3. How do they relate? Well, +2 plus +3, or plus 3, is equal to +5. And +2 multiplied by +3 is equal to +6. So these two numbers, when they add together, they give me this +5. And these two numbers, when they multiply together, they give me this +6. So in general, if we have our, I don't think I want to write this as a generic sequence right now. I think I'm going to stick with numbers. So let's see if we can apply this. So the relationship, what relationship is there? The coefficients add to make the middle term, and they multiply to make the last term. So we are interested in the sum and the product of these factors. And we're going to make use of these ideas, sum and product, to factor this. So let's go on and actually do some examples here. Now there's a short form, but I'll start off, we'll do it the long way, we'll write it out. So we're interested in our sum. So what is the sum that we want? Looking back at our original one, we want to add these two factors to add up to be 5. So this one is our sum, and the last one, the constant, is our product. So our sum is here. Our sum is going to be 4. Our product is going to be 3. So, and this is +3. That's important because how do you get a product of +3? You can multiply two positives together, or you can multiply two negatives together. So how do we get a product of 3? So take a look at the number 3. Well, what can I do? This one's pretty simple. It's going to be 1 times 3, or 3 times 1, or negative 1 times negative 3, or negative 3 times negative 1. Those are the only ways that I can multiply integers. It's always going to be integers. That's the only way I can multiply these integers together to get a product of 3. And then what we ask ourselves is, so out of these, which of these pairs of numbers adds up to give me this sum of 4? So 1 and 3 add up to 4. 3 and 1 add up to 4. Now it turns out, this is what I said before, that for the time being, when the coefficient in front of the x squared is 1, we actually, reversing the order of our product is the same thing. So whether we pick the first one, 1 times 3 or 3 times 1, doesn't matter. So this one works. Negative 1 and negative 3, when you add those together, that's negative 4. So you can see here, the fact that my sum is positive, well, that's going to require me to add up positive numbers. It doesn't make sense to have negatives, so these get eliminated. And so it turns out that my integers, which is what we're interested in, the integer factors are going to be the numbers 1 and the numbers 3, or the number 3. So that means that this can be written as, we need the x because x times x gives me x squared, so I know I need an x at the beginning of each, and I'm going to have x plus 1 and x plus 3. So now I have taken this quadratic expression in standard form, and I've rewritten it in factored form. And if you wanted to confirm that this was actually correct, then what you would do is you would expand these pairs of brackets back out and show yourself that you end up back where you started again. These mathematical operations have to be reversible. If you can't reverse them and show that you can get back to where you came from, you've made a mistake. Your answer is wrong. Now, a short form for this, you can still do it this way if you like to, but sum product integers, so in mathematics, we've got something, just a little mnemonic to help us remember. It's called SPI, and that is sum product and integers. So we ask ourselves, well, what's the sum? In this case, the sum is the negative 8, and you do need to remember to bring those signs over. The product is positive 12. And so we ask ourselves, you'll hopefully, once you do this enough, you'll get to the point where you can do a lot of this in your head. But I'm not going to take those chances. How do I multiply two integers together to end up with positive 12? I could do 1 times 12, 2 times 6, 3 times 4, and as soon as I get to this where I'm reversing them, 4 times 3, I realize, oh, when it's just a 1x squared, I don't need to consider the reversing. So it's just 4 times 3. And I have to consider the negatives. Well, to get a positive product, I need negative 1 times negative 12. I need negative 2 times negative 6. And I need negative 3 times negative 4. It's a good idea to be really methodical about this. Now, we could have saved ourselves some time and effort here because my sum has to be negative 8. Is there any way in the world for me to take two positive numbers and have them add up to be negative? No. So I could have actually dispensed with all of those right away. And now, ask yourself, what is negative 1 plus negative 12? That's negative 13. Nope. Negative 2 plus negative 6. That's negative 8. That works. As soon as you get one answer, technically you're done. But I'm just going to show here, negative 3 and negative 4, that's negative 7. That also doesn't work. So the one answer I could get is the answer. So my integers are negative 2 and negative 6. So I write this as x minus 2, x minus 6. And that's it. I've taken what's known as a simple quadratic trinomial, or just a simple trinomial, and I've rewritten it in factored form. Okay, and that's it for this lesson on factoring trinomials.